Kia ora. Now, hi to my welcome to App Smashing, the series all about combining digital tools for fun and ideally learning opportunities. And this is the 5th episode in the series. So welcome. Hopefully people are sorting out their sound, coming in, arriving. So here in front of the camera, my name is Donald, if you haven't joined me before, and behind the camera through the ether is Mel, who is going to be looking after chat, posting in links for people to follow. So I've seen that there is a bit.ly link there for the slides. So you click on that and get access to the slides. If you like to follow along, you're very welcome to just enjoy the webinar as it is at the moment. And when the recording goes up on YouTube, then I'll also share a link to the slides then. So you'll get all of these, access to all of these slides then. So a few people are just still arriving, which is great. Welcome. So today we are going to be looking at design by coding. So we're going to be looking at using block coding to create interesting designs of things and using two really fun apps, one that is Scratch, which lots of people know about, and another that is Tinkercad, which recently had block coding added to the suite of tools that are available. So we'll have a look at that as well and see what possibilities that opens up. So before we properly get started and into it, I'm going to start with Karakia Timatanga. You're very welcome to join in. Tēnei te Māori, ka piki ake ki te rangi e tu nei, he rangi atua, he rangi tipua, he rangi tāwhito. Kia whiti ko te mātaranga, kia tau ko te maramatanga. Whaia kia tata puratia kia mau. Homie, huie, tai kie. So that karakia came to us through the work that we did with the Kia Takatu and Matahiko Digital Readiness Program. And that was great fun. Met lots of really fantastic teachers through that process. And so this work, these webinars that I'm doing are kind of continuation on that idea. And that's why I'm choosing to use this particular karakia. Who am I? Why am I on the side of the camera? Ko wai matau. So ko Donald Tokuingwa. I work at Te Papa. I'm one of the learning specialists here. And for the last 5 years, my role has been a lot to do with using digital technology for creative responses in the museum, responding to the collections and exhibitions, and giving students and teachers the opportunity to have their say about why the taonga of Te Papa and of the nation are important to them. And so I have, and the learning team at Te Papa have had lots of opportunities to research and discover really cool digital tools that enable really great collaboration and creativity. And this webinar series is about sharing those tools with you. So that's why I'm here. And the challenge for this particular webinar, as presented last week, is to combine Tinkercad with Scratch. So each week, we are taking one of the apps from the previous week and smashing it together with a new app. And so last week, we were looking at Scratch, and so we've added Tinkercad to that tool suite. And the reason we're smashing apps together is that because no one tool can ever do everything. And by combining tools together, that gives you new opportunities about what it is that you can create. And so this is an opportunity to see what the possibilities are of combining Tinkercad and Scratch. Where do those tools intersect? What can you create by using those two tools that you wouldn't be able to make either on their own or without contrasting them in some way? so that is the challenge today, Tinkercad and Scratch. After this webinar, you'll be inspired to have a look at Scratch and Tinkercad in new ways that you might not have looked at them before. All right, so Scratch, what is it? For those who don't know, it's a free online kid-friendly coding platform, which uses block coding. We've done a bunch of webinars and such on Scratch before. So there's links in here that will take you to those webinars and those resources. It's really kid-friendly. It's really fun. There's lots and lots of resources out there to use. And you can, one of the really great things about it is that in the last couple of years, Scratch have been investing in the resources to convert the entire user interface into different languages, so that it can be used by fluent speakers of lots of different languages, not just English. And so you can actually convert this into Te Reo Māori, which is really great. Allows you to practice your Te Reo Māori in a new context, which is really fun. And it also allows you to share and remix projects. So the coding that you do in Scratch, you can share it to the community. You can also find projects that other people have made, and you can remix those projects for yourself. So you can investigate what those projects are and make your own adaptations, which is really useful. Tinkercad, on the other hand, is normally a 3D design tool. So the purpose of Tinkercad is to basically use basic primitive shapes like cubes and spheres and triangular pyramids and things like that, and to basically kind of pile those on top of each other, kind of like playing with wooden blocks. It has a really intuitive interface. It's also been around for quite a long time. And so they've been developing this toolkit for a very long time. It's a really lovely place to go and visualize 3D designs. And you can create 3D designs very quickly. If you have access to something like Lego wooden blocks, then you can generate similar ideas physically in front of you. But it's a really useful skill set to be able to understand how to use a digital device to create 3D designs, because you can store them more easily and you can share them more easily. And this is really important for the digital technology progress outcomes, to be able to understand how that works. You can also, within Tinkercad, you can visualize the designs that you make as Lego or Minecraft designs. So if you have students who are particularly interested in either of those platforms or those tool sets, then that can be a really fun way of getting them to explore new ideas about things that they can design and create. And you can create things in often much faster in Tinkercad than you would in Minecraft or Lego, because all of the pieces are just there. You don't have to rifle around in your inventory to find those things. So that's really nice. It's a really great interface. It also allows you to work collaboratively, and you can also annotate your digital designs. So you can basically justify your design decisions as you're going, which is really great. So that is what Tinkercad is usually used for, but it has this other kind of this new mode where you can generate your 3D designs by using block coding. So the easiest way to explain that is for us to just get right into it. So Katafiwa, let's give it a go. So I'm gonna X out of that. And the first thing I'm gonna do is I'm gonna jump into Scratch. So this is what, this is Scratch here, and I'm going to open up the project that I was making for this webinar. So I thought it would be fun to use Scratch to design a Christmas tree. So today is all about design by coding. So we're going to design a Christmas tree. And the way that Scratch works is, I'm going to have to zoom out a little bit, see all my blocks. The way that Scratch works is you have these pieces of code. All of these on the left-hand side are pieces of code. And every single one of them is like a little puzzle piece, and you can drag and drop them together. And Scratch is clever enough that it only lets you snap together pieces that can go together. So that reduces the chance of failure with it. And what I can do is I can set up a whole system to draw shapes. So what I might just do is I'm going to break my code. Here we go. I'm going to break my code so that it doesn't do all of the things to begin with. And we'll just add these together to see the pieces come together. So I've set it up so that when the flag is clicked, my code is going to start. And you'll see that here. This is one of the event blocks. And it will start calling this line of code down here. So if I hit that, okay, it's got down to the point where it's going to try and call a piece of code. It says broadcast Rakow and wait. And because Rakow doesn't do anything, my code isn't going to do anything. So I'm going to have to put this bit of code back together. So the first thing it's going to do is erase everything, go to a location that I've told it, point in a direction, and then turn a number of degrees. And then it's going to start drawing my Rakow. There we go. So it happened very, very quickly, but I can do that again. So you'll see repeating 3 times, it's going to create 3 triangles. And these triangles are moving a number of steps, rotating 120 degrees, moving a number of steps, rotating 120 degrees, moving a number of steps. And then it's going to lift the pen, change the pen size, and keep on going. These pen blocks are not normally found in Scratch blocks, so you have to go to these add extension blocks down here, and there's a whole lot of fun extensions that you can add to Scratch, which is great. This pen function is really valuable because it allows you to explore direction and orientation in a way that, and visualize that in a way that is sometimes hard to do in Scratch. So I really like this pen tool. So here we're creating a series of triangles, and when they're stacked on top of each other like that, I'd say that they look quite Christmas tree-like, but there's some elements missing. So we need to do the base. And so at the moment, our code has got as far as broadcasting Rakow, it's communicating that, and then we are going to broadcast the base and wait. So I'm going to add my code back into the base. And it's going to change, it's going to move to a location, change the color of the pen. So it's going to draw in this brown color next. And then it's going to draw 3 sides of, because this is 90 degrees, a square. So let's have a look at that. Here we go. And so that more or less looks like a Christmas tree. And then I've just got a couple of extra little pieces of code here. So Whakamutunga. So after it's finished drawing the tree, it broadcasts Whakamutunga to finish. And so this little star, this sprite that I have here, is going to say Merikire Mete. And it's also going to glide to the top of the tree. So let's have a look at that. Here we go. And does a little dance. So that's, in order to do all of that, it took me quite a lot of trial and error to figure it out. But the trial and the error is the key thing. If you have students that you want to do this kind of a thing with, I recommend as the teacher creating a basic set. It could just be 1 triangle. Could be literally just this piece of code here. This repeat 3 times. And if I wanted to, let's just do this. Erase everything. And I'm going to, with a new event, I'm going to do it when I press the space key. And I'm going to need to set the pen color. And I'm going to need to go to a location. I think where it is absolutely fine for now. Go to a location and do that. And so now if I hit space, it's going to draw a triangle. All right. If all you have is this piece of code here for your students and tell them that you can tell them to break this code, change any element that they want, and explore ways that they can adapt it. Kids are incredibly creative when they have the tools available to them. And if it was me, I would start with something very basic to just get them using Scratch to draw things and exploring what happens when they change different variables. And from there, you can build up their understanding about what is possible and then let them explore what they can design using this toolkit. This is a toolkit. There's so many possibilities that you can do with the Scratch drawing function. But being able to talk about angles and measurement and design and shapes is pretty fun and pretty cool. One of the limitations of Scratch is that everything is kind of limited to 2 dimensions. And so that is where Tinkercad can help us. So I'm just going to head to my Tinkercad tab. Here we go. And what I might just do is show you what Tinkercad normally looks like, because some people might not be familiar with that. And so Tinkercad, the basic setup of Tinkercad, so it's just a model I've made in the past. And so this is what Tinkercad normally looks like. You have these basic shapes down here that you can drag onto the work plane, and you can make them bigger and smaller and change their color and rotate things. And you can group objects together to create weird and wonderful things. And if I don't make it multicolored, there we go. So there's like one strange shape, if you will. And so that is the purpose of Tinkercad. Normally is taking shapes, combining them together, and creating 3D designs of things. That's what Tinkercad is normally designed for. But what they have done is they have created code blocks which function very similarly to Scratch, where you have these pieces of code that you snap together, but what they are used for is for creating shapes and creating designs. So I'm going to go into my Christmas tree design again, and I'm going to break my code once again so that we can see, because this is some complicated stuff down here. We don't really need to see that at the moment. So I'm going to break this code and we'll build it back up again. And you can see what each piece of code does. All right. And the way that Tinkercad works as well is that it just starts at the top left and reads down. So whatever order you put things in, then it will create those things. And the most important block in Tinkercad is create new object. So with that block, that is the main thing. You want to create objects in Tinkercad, and you want to modify those objects. So the first object I'm going to create, unlike in Scratch where I start at the top of the tree and work down, in Tinkercad I'm going to start with the base and work up. So with this, I can leave speed at medium.
John, could I just ask, is the coding elements, are they all within Tinkercad already?
Yeah. So it's an option within Tinkercad. So if I go to my Tinkercad, when you have a Tinkercad account, and it's just a free email sign up, which is really easy. when you launch your account, this is what your dashboard looks like. And Code Blocks is just on the left-hand side here. There's also loads of free lessons so you can learn all about the different things. And if you go to Code Blocks, then you have your own designs. If you create a new code block, then it takes you to quick start guide, activities, starter designs. There's lots and lots of content in there already for people to explore. And so you don't really have to understand how any of this works. Tinkercad has done a really good job to give you the tools to be able to explore it for yourself.
Perfect, thank you.
So I'm going to press play on my script on my code blocks in Tinkercad, and we'll see what happens. Okay. So it's going to run the code anyway, because like I said, it just attaches things. It just does things in turn. The breaking of the code doesn't work the same in Tinkercad as it does in Scratch. So I'm just going to zoom out on this, and I'll scroll down as I go so that we can see what's going on. When it gets to it, it's going to create one Christmas tree that's a bit like this, and then it's actually going to replicate that Christmas tree multiple times to kind of create a Christmas tree forest, if you will. And that is one of the things about coding, is that if you can create one, you can create multiples very quickly, because you can just use the code, you can use the script, you can use the computer to do all of the extra work, all of the repetition, all of the copying and pasting for you. You don't need to individually do everything. And if you can explore the ideas of variables, variables are really, really valuable, then you can use variables to control your code. And what I'm trying to do with this is not necessarily show you how those things work, but at least give you an idea about the value of these things. And if you use the lessons and tutorials that are in Scratch and Tinkercad already, then you should be able to follow those tutorials to understand what the power of variables is, for instance. All right, so start again from the beginning. Let's have a look at a Christmas tree. So it creates this piece, see it going down 3 times, it creates 3 cones, or 4 cones, in fact, because it duplicates itself. And then it creates a star, makes it small, puts it on the top of the tree, groups that entire object. And now, 15 times, it's going to create new trees. And each time, it sets the size to the size of it divided by 1.1. So that's going to reduce the size of it each time. And I had to, just by trial and error, I'm not a math whiz. I just had to use my use trial and error to see what I could do. It was very easy to make them bigger one after the other. And I had to explore different ways to make them smaller each time. There we go. So we now have a random array of Christmas trees. And if I repeated this code again, I could do it very quickly. I could just turn the speed up. And I could do this again very quickly. And it makes a different forest of Christmas trees. Once again. And so you can use this to explore like design of areas, of spaces, of things. You could also use this to model processes changing through time as well. So we're 5 minutes from the end. I'm going to jump back to my slides, but that hopefully gives you an idea about what the powers and possibilities are with block coding with these tools. And hopefully gets you excited about trying some of these things for yourself. So I'm going to jump back to my slides. All right, so we tried that. So what are the connections to the curriculum? So of course, these digital tools and creating things in this way, of course, it connects to the digital technology curriculum, but it also connects to numeracy and art and design and languages if you want. There's lots of really interesting things about creating patterns, and also in Scratch, for instance, converting Scratch into Te Reo Māori and talking about directions and talking about numbers, and using Scratch and Tinkercad to demonstrate students' understanding of what those things mean. So that's really fun. It's a nice way of creating it in the real world, but also students demonstrating that creating outputs which actually represent their understanding of those ideas. Both Scratch and Tinkercad allow you to visualize processes through time. This is what I said earlier. So you could create a visualization which is something in slow motion. Maybe it's something growing in slow motion, or it could be something sped up, like an eclipse, or moon orbiting the Earth, or whatever it is you want. It could be, it could be scientific models that are either much faster than they appear in real life or much slower than they appear in real life. Scratch, if you have the ability to screen record, and there are screen recording apps, that allows you to basically play your visualization and record it and export it as a video. Tinkercad code blocks, you can actually export it as a GIF, which is just an image file. And that's one of the things that I shared on Facebook and LinkedIn earlier this week to kind of promote this particular webinar. So it's really cool to be able to create outputs like this and to be able to capture them in formats that are shareable more widely as well. So that is what Tinkercad and Scratch can do together. The Wero for next week is going to be Tinkercad and SculptGL. And so SculptGL, for those who don't know, is a kind of virtual clay modeling tool. And so we're going to be looking at, and Tinkercad is very kind of architectural and square lines and kind of geometric solids. And SculptGL is a very tactile 3D design tool. So we're going to be contrasting what they can do together and see what happens when we take objects from one of these tools and smash them into the other, and see what the limitations of that are. So that's going to be really, really fun. It's tutu time. I highly recommend that you jump into Scratch and Tinkercad and play with them yourselves and just see what the possibilities are. There's lots of really cool tutorials and lessons and stuff out there for both of those. Now is a really good time for questions. So I'm gonna get Mel to relay your questions to me. So if you've got any questions, put them in the chat now, and Mel's going to ask them to me. Are there any questions, Mel?
Not yet, but a couple of comments saying that this is really cool 3D use of Scratch style coding, just that people are enjoying learning about this.
Sweet, great. Wonderful.
Just some happy people, no questions.
Sweet. All right. So upcoming webinars. So not only am I doing webinars, but it's just like webinar, like wild town here at the learning team at Te Papa. We have within the learning team, we have Te Pū Te Aki Mana Taonga, which is the Association for Educators Outside the Classroom. And they have been doing lots of great work to support educators in museums and galleries all up and down the country. And so they've got really cool webinars as well. And so we've got educators from Te Matatoa, the National Army Museum, and also New Zealand Maritime Museum in Auckland. And they're going to be talking about how they've been adapting some of their face-to-face programs into digital, online, virtual programs as well. So that could be really interesting to you. as a space to kind of understand what the possibilities are for programs coming to your school. So I highly recommend checking that out. And if there's no further questions, then we can do a karakia whakamutunga. I was just double checking the chat there, just to make sure there's nothing. So we're going to karakia whakamutunga, and hopefully I will see everybody again next week. This is being recorded, so I will share the recording with you all with links to the slides. Karakia whakamutunga. Tēnei te Māori ka heke iho ki te whenua e takoto nei. He rangi atua, he rangi tipua, he rangi tāwhito. I whiti ko te mātaranga, i tau ko te maramatanga. Tēnei ka hekitia kia wātea, haumi e, hui e, tai ki e. Mā te wā.